Hi everyone. This is our look at pH curves. pH curves are graphs or sometimes just curves without any values on them. What they do is they show the pH of the sample during a titration. And this could be when we're adding an acid to a base or adding a base to an acid. This is never about pOH. It's really specifically pH only. And remember, the sample is the container at the bottom of the experiment. Not in the burette, down in the flask at the bottom is the sample of the titration. There's a couple of things to keep in mind for each of our scenarios, and that's about the pH and something about the shape of the graph itself. Strong acids are going to have a pH less than 2, and they're going to always match up with a really flat part of the graph. A weak acid is going to have a pH greater than 2, still below 7. It's an acid after all, but greater than 2. And there's going to be an incline, a sloped shape to the graph. Strong bases have a really high pH, greater than 12. And just like strong acids, they correspond with the flat section of the graph. Weak bases have a pH less than 12, still above 7, but less than 12. And just like weak acids, they go along with this with an inclined shape, a sloped shape. All of the scenarios that we're going to encounter are going to have a part of the graph that goes straight up and down. And the middle, the center of those vertical sections, is called the end point. Sometimes it's called the equivalence point. This is the place where the moles of the acid and the base are equal equivalence point. It's the moles that are equal there. It's not the volume, it's not the concentration, it's the moles that are the same at the center of the vertical section, at the equivalence point, at the end point. Sometimes we might even be asked to choose an indicator. Hey, here's a pH curve. What would be an appropriate indicator to use? We want to choose an indicator whose range from the table in the data booklet includes the endpoint. We'll see that in a minute. In the end, there's actually 8 possible scenarios for us, different combinations of strong and weak acids and bases. These first 4 scenarios, here I have SA for strong acid, SB for strong base. This is the addition of a strong base to a strong acid. Then a weak base added to a strong acid, a strong base added to a weak acid, and finally a weak base added to a weak acid. There's a couple of things to look for, and it's always about the pH and the shape of the graph itself. Here we started with strong acid. The pH is below 2, and it's flat. We added a strong base, so the pH came all the way up above 12, and it's also flat. Notice there's a vertical section there. Strong acid again, below 2, flat. Add to a weak base being added to it, the pH stays below 12, and look, it's really subtle. Here's flat for a strong base, but this one over here, it's slightly inclined for the weak base. This time, starting with a weak acid, the pH is above 2. You can see that slope there. We added a strong base to it. The pH went all the way up above 12, and again, there's that characteristic flat shape. A weak acid was above 2, it's inclined. A weak base stayed below 12 and likewise is inclined. We have all the opposite situations going here in our second group of 4. A strong acid added to a strong base, a weak acid added to a strong base, a strong acid added to a weak base, and a weak base added to a weak acid. We have these same features, only now going in the opposite direction. These first 4 all went up. These second 4 all coming down. We started with strong base, so it's above 12 and flat. We added a strong acid to it. It came all the way down below 2 and is likewise flat. The second one also started with a strong base. It's a pH above 12 and it's flat. We added a weak acid to it, so the pH came down, but it stayed above 2, and there's that inclined sloped shape. A weak base was below 12 and slanted. We added a strong acid to it. The pH came all the way down below 2 and has that flat shape. A weak base below 12, there's that incline. I exaggerated it only ever so slightly. There's that drop off, and then the pH stayed above 2 with that incline. These features are really going to help us to identify the type of pH curve we might encounter. We're not going to have to draw these ourselves. We're going to be provided with them. We're going to need to interpret what we have. That might mean saying what the scenario is. Hey, here's a graph. What does it represent? Or sometimes we might have to choose an indicator or do some extra interpretation. So now I've used a ruler to really accurately break down the axes here with pH on the y-axis and the volume of titrant added across the x-axis. You can see that this shape matches this one right here. This is the addition of a strong acid to a strong base. We had a base down below the burette as the sample. We were adding acid to it. Here all of the graphs have a vertical section. They all have a vertical section, including this one. And it's the center of the vertical section that corresponds to what we call the end point, the equivalence point. Now, we might have to do our best to judge where the center actually is, where I might call the center is different from you, but we'll be close. So I'm looking for the center here. It's about there. That's the center of the vertical section. It's the center of the vertical section. Okay? It corresponds to actually a couple of different things. There's the pH. Here, the pH of the endpoint looks to me like I got it right about 7. I'm going to call it 7.1. Looks like ever so slightly. If a different person called it 7.0 or even 6.9, that would be pretty close. Okay? It also corresponds to a volume added. The volume added at the end point. Here I'm going to say it's 15 milliliters. There's a whole bunch of questions we could be asked. Hey, here's a graph. What scenario does it correspond to? This one is a strong base titrated with a strong acid. We might be asked to read the graph to say, oh, what's the pH of the endpoint? So then we do our best to find the center of the vertical section and read the y-axis to say what the pH of the endpoint was. We might be asked how much titrant was added to get to the endpoint. Then find the middle of the vertical section and go down to read the volume. Sometimes when people see endpoint, they go to the end of the graph. Don't do that. Find the center of the vertical section and interpret the graph from there. What's the scenario? What was the pH of the endpoint? How much titrant was added to reach the endpoint? And finally, what would be an appropriate indicator to use? We decided already that the pH of the endpoint was 7.1. So we want to go to the data booklet and find an indicator whose range includes 7.1. Here, there's a couple of different possibilities. I see the range of 2 different indicators does the trick here. So I'm going to say choose. I'm going to say bromethymol blue. The range for bromethymol blue is 6.0 to 7.6. 7.1 is right in the range. That would be a good choice. I'm going to even say or. Right below bromethymol blue on the table is phenol red. Phenol red says 6.6 to 8. 7.1 is in the range. 7.1 is between 6.6 and 8. So this is phenol red. pH curves are graphical representations of what's going on with the pH during a titration. We might be adding a base to an acid or adding an acid to a base. We're always going to have a vertical section, which we need to interpret. If we pay attention to the pHs and the shapes of the graphs, we're going to be able to identify the scenario that we're being presented with. Most commonly, however, we'll be given a graph and asked these three sort of questions. What was the pH of the endpoint? How much volume did we have to add to get to the endpoint? Or what would be a good indicator to choose? And I hope that helps.